Okay, in section 4 of Algebra 2, we're going to talk about compound inequalities. And to look at compound inequalities, we're just going to start with the definition. A compound inequality is a statement with two inequalities joined by an and or an or. And as we go through this section, you're going to see a lot of and or compound inequalities. Those are the two types of inequalities, and we're actually going to focus first on the and inequalities. So what is an and inequality? Well, it's pretty simple. An and inequality is just a compound inequality where both inequalities must be true. So, just a quick example. You might have something that says x is less than 5 and x is greater than 1. So both of those must be true, and they're combined with an and. Another way you could actually write this would be, I'll put it in red off to the side. You could also say that's the same thing as that should be an x in there, is between 1 and 5. So both of those are the same way of writing x is less than 5 and x is greater than 1. So let's look at our first example of solving and inequalities. We're going to solve these very similar to regular inequalities, but we have two different types to solve in one question, and then it says also to express their solution in interval notation. So using the interval notation we learned from last section. So on this first one, x minus 7 is less than 2. We're just going to add 7 over. So you get x is less than 9. On the second one, we'll subtract 1 first, and then divide 2. So x is less than 4. So if this is an and statement, both of these have to be true. The number that works for these inequalities has to be less than 9 and less than 4. That means, even if we look at it on a number line, sometimes that helps if you sketch out a number line. If this is 0, 4 is here, so it has to be less than 4. 9's up here, it has to be less than 9 as well. That means anything that overlaps is a solution. So really, our solutions that fit both of them fall anywhere on this side of 4. How do I write that as interval notation? Well, anything less than 4 fits this inequality, so I'm going to say from negative infinity all the way up to 4. Don't include the 4 because it's just less than, and then you always put a parenthesis with the infinity. So here is our solution set in interval notation. Looking at the next one, we have 2x plus 3 is less than 6. Let's start with that. So I'm going to solve that by subtracting 3, dividing by 2. Our first solution is x is less than 3/2, or 1.5. We also have to solve this one by subtracting 1, dividing by negative 3. Remembering your inequality rules, if we divide by a negative, divide or multiplying by a negative, flips the inequality sign. So maybe I'll make a note off to the side. Multiply or dividing by a negative number flips inequality. Don't forget about that. So we have two statements. We have one and we have the other. X is less than 3/2 and x is greater than 3. Greater than or equal to 3, excuse me. So let's look at this one. If I have 0 here, 3/2 and 3. So if it's less than 3/2 and it's greater than or equal to, so I'm going to close that because it can equal it, 3. The and has to apply to both, so we're looking for overlapping region, and there is none. So really, there is no solution. There's no value for x that'll work for this one and for this one. That'll satisfy both equations. So no solution here. For the last one in this section, we have another and inequality, so let's look at solving both of these separately. I'm going to go ahead and subtract the 10. 2x is less than -2. Divide by 2. X is less than -1. So there's our first value. On the next, I'm going to add 15. From there, -3x is less than or equal to -20. Divide both sides by -3. Again, we have dividing by a negative, so that flips the inequality sign to 20/3. Or you can think of it as 6.6 repeating. Same thing. So I need to write this as, here's my solution. I'll put an and in there. Both have to be true. I need to write this as a compound inequality. Let me go to the number line. Here's 0, -1, and 20/3 is about 6.6. So I'll put 20/3 here. Has to be less than -1 and greater than or equal to. So we're looking for anytime they overlap because it's an and. Well, again, we have them that don't overlap at all. So there is no solution for this one. If we continue looking at and inequalities, but what's called compacted form. Compacted form is when you combine and inequalities into one inequality. So we had seen this example already. Our example was x is less than 5 and x is greater than 1. Since this is possible to have a number less than 5 and greater than 1, we combined it into one inequality. We said x is in the middle. Your inequalities actually face the same way, and it's shoved between 1 and 5. So this would be an example of a compacted form. And we can solve these types of compacted forms. Looking at the first example, this says 1 minus x is in between 5 and 9. Or 1 minus x is greater than 5, 1 minus x is also less than 9. If we solve this, we're going to solve it just like another inequality, but it has 3 parts. Here's one part, here's one part, and then there's a third part. So that means what we do to the inside to get x by itself, we have to do to all 3 parts. And to get x by itself, I'm going to start by subtracting 1, because those cancel. That means I subtract 1 on the left, I subtract 1 on the right. 5 minus 1 is 4. We have negative x on the inside still, and we have 8. Still need to keep going, divide by -1 to get x by itself. Well, dividing by a negative tells us we need to flip our signs. Now you notice in compacted form, if I take you up to this compacted form, it's backwards than what we have here. So let's flip this thing all the way around and say -8, x, and -4. So x is in between -8 and -4. What does that look like on a number line? Well, 0's up here, -4, -8. That means x is somewhere, not including -8 and -4, between the two. All those in between are solutions, which makes our interval notation pretty easy. The lowest point is -8, all the way up to -4, parentheses because you don't include them. And there's your solution set. Looking at our next example, I'm going to start by subtracting 1 to work on getting x by itself inside. So I got to do that to all three parts. Well, the middle, you get x over 2. On the left, -4. Whoops. On the right, +4. Now to get x by itself, I need to multiply by 2 to all three parts. -8 is less than or equal to x, which is less than or equal to 8. Let me clear that x up a little bit. So, to work on putting this in interval notation, again, I'm going to create a number line first just to make it easy. There's 0. If 8 up here, -8 would be the same distance to the left. And it's anything between these numbers, but also including these numbers because it can be equal to. So I'm going to fill in the circles and say anything between is a solution. On interval notation, the lowest point it could be is -8, all the way up to 8, and we have to include these square brackets. The second type of compound inequality we talked about was the OR inequality. And an OR inequality means that either one or the other inequality must be true. So this time it's not both, it's only one or the other. Directions for the next one are very similar. Solve and express in interval notation. We're going to solve this just like the ands. We have two separate inequalities. I'm going to solve the first one by adding 2. 3x is greater than or equal to 12. Divide by 3. So x is greater than or equal to 4. That's our first option. Or let's solve this one by adding 6. Less than or equal to positive 2, excuse me. -4 plus 6 is positive 2. So let me carry that down because that's already done. X is less than or equal to 2. What does this look like in interval notation? Well, we had some practice with these before in section 3. But let's remind ourselves if that's 0, 2, and then 4 is up here. Those are the numbers we need. First is x is greater than or equal to 4. Looks like that. Second is x is less than or equal to 2. But this time we don't need overlapping solutions because it's an OR. That means only one or the other have to be true. It doesn't have to meet both qualifications. So how do I write this in interval notation? Well, let's piece it up. This left side here would be from -infinity to 2. We're not going to include -infinity, but we definitely want to include 2. And remember, OR is represented with a union symbol, the U. The next piece would be from 4, include 4, all the way up to infinity. Any of these solutions would work in our original question. And for our final example, we've got one more OR inequality. Let's solve these individually again by adding 7. So we have x is less than or equal to 6, or, well, let's add 6 first. 2x is greater than 13, divide by 2. X is greater than 13 halves. Let me carry this one down so it looks neat. So we have one or the other. Keep in mind 13 halves, what, 6.5? So it's either less than or equal to 6 or greater than 6.5. In interval notation, we can put 0 here. That means if 6 is here, 13 halves or 6.5 is right beside it. Less than or equal to 6. We'll start by graphing that one on the number line. Greater than 13 halves. Interval notation. Take it piece by piece. The first piece would be from negative infinity to 6. Never include infinities. We're definitely including the 6. Or, again, tells us that it's a union. 13 halves, don't include it. To infinity, don't include that. Here's our interval notation for the original question.